Hey everyone, welcome back to What's Inside. This is going to be an extension of our past season with the Lego Elegoo kit. Because there were just so many amazing pieces. There's so many amazing components that I just want to go over with you guys. And then it's just gonna be me with you guys today. Josh is taking some time off. He wants to take a break, but you guys still have me, and I'm going to explain. I'm going to walk you guys through each and every, like the function, what is the description of the piece. And so today's episode, we're going to be doing the ultrasonic component here and what it does. If you think about it in this way of, it's kind of like a bat when it uses echolocation, which it sends the sound waves out and then it receives the sound waves and then it calculates how much time it takes to receive that sound wave. And that's kind of what it basically does, but I'm going to go more in depth about it in the next section of this video. Hey everyone, welcome to the more in-depth analysis of this very amazing piece right here. We see this like the ultrasonic sensor, and so what it does basically, it, like I said, it measures the distance using sound waves, and the whole idea of this is to send these pulses, and it measures like the echo time to calculate the distance, like how far apart something is. And so where we use this in obstacle detection, we use this in robotics, parking sensors, and automation. And also moving back to the idea of like a bat using the echolocation. So it basically just sends out the sound waves, and as humans, we cannot hear them, but it will measure how long they take to bounce back. And with just a few lines of Arduino code, you can measure distances with millimeter precision. No lasers are needed. And if you want to build a robot that avoids the obstacles or just an automatic parking system, this is just essentially the component that you will need to do so. And just some basics of this component. It is an HC SR04 ultrasonic module. Its range is 2 centimeters to 400 centimeters. Its accuracy is within 3 millimeters. It operates at 5 volts and it has 4 pins, as you can see right here. It has, sorry, it's a little unclear right here, but it's the, right here we have the VCC, the trig, the echo, and the GND. And so right here, each of them have like their own different function. The trig pin, which is the one right here. The second one from the right, it's the one that sends the pulse. The echo pin listens for it. And the time delay between the sending and the receiving just essentially tells you the distance. And then as you can see from this component, we had these two circular things. One is right here. There's another one right here. So these two things are the transceiver and the receiver. As you can see right here, there is a T and there's an R. So which means that this one is the transceiver, noted by the T, and this is the receiver, noted by the R. And so the transceiver is the one that ultimately sends out the sound, and then it might hit something here, and then the sound wave is ultimately going to come back through the receiver. And so basically just how it works in whatever you may want to use this piece for. So it sends basically from the Arduino, like the lines of code that you might be using it for. It sends out a short high pulse to the trig pin, and then the sensor ultimately emits a ultrasonic wave at 40 kilohertz. The wave bounces off an object and then returns, and then the echo pin goes high for a time proportional to distance. And just a quick formula, it's just the time multiplied by the speed and then divided by 2. Because it accounts for the round trip. And then going more into detail about these 4 pins. So they actually don't operate at the same voltage, or they are the Arduino wiring is actually different. So for the VCC here, it correlates to the 5 volts Arduino pin. The tray is a 9, Echo is 10, and GND, which is the ground, will also go back to the ground. So when you're using this, sound usually travels at around 340 meters per second in the air, in 20 degrees Celsius, but changes in temperature or humidity may slightly affect the readings, which is a good fact to know, especially when you're working outdoors and you're trying to test your robot, your automated parking system. It's really good because these may slightly affect your readings, and but universally you can calculate how much distance something is from your object using this sensor. In here, I want to keep this video pretty short since I know some of your attention spans are very cooked. Obviously, I do want to go more in depth in some of these other things, for example, troubleshooting, maybe even some example codes, a quick summary, but obviously we do not have that much time on our hands. But if you want to get more information about this component, feel free to either shoot us an email or check us a website to contact us, or feel free to just leave us a comment. And yeah, that's basically it for this video. Feel free to reach out to us. I really hope that you guys all have learned something with this very cool, interesting piece. We can get into like the back cover of it in a future video if you guys would like. Yeah, your feedback is greatly appreciated. I really hope you guys learned something, and remember to stay curious because that's what's inside.